students, today we shall start with the next lesson, that is machine. What is machine? You must have used a lot of machine in your daily life, and you also studied about machine from class 6 onwards. Machine is any simple device that makes your work easier. You must have seen a very simple machine also, must have seen very heavy machines also. We talk about simple machine. Simple machine is a machine that makes your work easier. How? Like for example, you have to open the nut, a rusted nut. Use wrench. Okay? You have to lift water from the well. You use a pulley to lift the water from the well. It is easier to pull down than to pull up. So we use a pulley to lift a bucket from the well. So there are a lot of machines that are being used in our daily life. Now, why do we use machine? Or what are the functions of the machine? Why are machines being used? So let us first discuss the different functions of the machines. Okay, we are going to discuss different functions of simple machines. The first function is it is acting as a force multiplier. What do you mean by force multiplier? You have to lift a heavy load by applying a lesser effort. Like for example, your car tire gets flat. You have to change the car. So the car needs to be lifted up. What do you use? You use a jack. So we can lift the car by using a jack. We apply a very small amount of force on the jack and it lifts up a heavy load. So that is an example where the effort applied is smaller and the load lifted is bigger. So it is acting as a force multiplier. Similarly, to carry load, we use a wheelbarrow. A wheelbarrow is acting as a force multiplier. The second one is change point of application or effort to a convenient point. Point of application of the effort change to a convenient point. You all are riding bicycle. The rear wheel of the bicycle is to be rotated. So you must have seen that the rear wheel of the bicycle is connected by a chain to a toothed wheel. And on the toothed wheel we have got a paddle. So when you rotate the paddle, the rear wheel is also getting rotated. So it is convenient to rotate the rear wheel by paddling at the toothed wheel. So we have changed the point of application force. Instead of applying the effort on the rear wheel, we are applying the effort on the paddle that is connected to the toothed wheel. That is the second function of the simple machine. The third function, in changing the direction to a convenient direction or direction of effort to a convenient direction. That is the third function. Now, the very simple example of this is lifting water bucket from the well or from inside the well. Okay, it can be lifted in the direction, upward direction. So if suppose we have got a 20 kilogram bucket filled with water inside the well, we start lifting it out. Now what do we do? In the second case, we apply a pulley system. We have a single fixed pulley, put the rope over the single fixed pulley and then we lift in the downward direction. Now what we have changed? Earlier we were simply lifting it up in vertically opposite direction, that is vertically upward direction. So we were finding it difficult to be lifted up. Why? Because we were working against the gravity. Now what we have done? We have taken a simple pulley, a single fixed pulley, and we have put the rope over it. Now we can even use our weight in the downward direction to lift up the pulley. So what we have done here? We have changed the direction of the effort. Earlier the effort was in the upward direction, now the effort is in the downward direction. The fourth point is for obtaining gain in speed. Now for obtaining gain in speed, it means that the load should move by a greater movement of load by a smaller movement of effort. Like what we are doing when we are cutting cloth, we are using a scissor. So the handle of the scissor moves to a smaller distance than the blades of the scissor. The blades move to a greater distance in the given time than the handles that are moving in the same time. So the speed of the blade is greater than the speed of the handle. As a result, there is a gain in speed. So these are the four functions of machine. If we connect them together, what do we get? We get the definition of machine. A machine is a device which we can either overcome a large resistive force or load at some point by applying a small force at a convenient point and in a desired direction, or by which we can obtain a gain in speed. That's the definition, which includes all the important functions of the machines. Okay. Next we have technical terms that are related to machine. There are a few technical terms that are related to machine. The first one is load. What is load? The load is the resistive force that is to be overcome by the machine. So what is load? Load is nothing but resistive force. जिस force को हमें overcome करना है. So load is a resistive force or an opposing force that is to be overcome by the machine. So it is force. What is it? Opposing force. What is it? Opposing force. So unit, SI unit is Newton. Okay. Then the second term is effort. What is effort? Effort is another force. Force which overcomes the load. What is effort? Effort is a force that is applied on the machine to overcome the load. It is again force. Again the SI unit is Newton. Is it clear? Then the third one is mechanical advantage. Mechanical advantage. An important term because we use machine to make our work easier. So it is mechanical advantage. अगर हमें कम फोर्स लगाना पड़े ज़्यादा लोड को उठाने के लिए तभी हमें मशीन का फायदा नजर आता है. So mechanical advantage MA is the ratio of load to effort. What is mechanical advantage? Mechanical advantage is the ratio of the load to effort. Okay, load that is exerted over the machine to the effort applied on the machine. SI unit, load in Newton, effort in Newton, both the units cancel out, it's a pure ratio. It has got no unit. It has got no unit. Now, in this formula gives you three conditions. So it's a ratio of load to effort. It will give you three conditions. First one, MA greater than 1. Second one, MA equal to 1. Third one, MA less than 1. So we can have, from this formula, we can have three kind of machines. One, where the mechanical advantage is greater than 1. How greater than 1? If the load lifted is more than the effort applied. Load lifted by the machine is greater than the effort applied, then it is having mechanical advantage greater than 1. Then this is used as a force multiplier. second one, in this case, if load is equal to effort, if load equal to effort, then MA will be equal to 1. It is used for changing the direction. Okay, it is used for changing the direction of the effort applied. Changing the direction. Change direction of effort. And third one, if load is smaller than effort, then it is used for gain in speed. Okay, then it is used as for gain in speed. So all machines can have either mechanical advantage greater than 1, equal to 1 or less than 1. If the mechanical advantage of the machine is greater than 1, that is used as a force multiplier. If mechanical advantage is equal to 1, then it is used for changing the direction of the effort applied. And if mechanical advantage is less than 1, then it is used for gain in speed. Now, unit of mechanical advantage, it is a pure ratio, because force upon force, load is a force, effort is also force, so it has got no unit. The next important term is velocity ratio. Velocity ratio is the ratio of the velocity of effort to the velocity of load. Okay, what is velocity ratio? Velocity ratio is the ratio of the velocity of the effort applied to the velocity of the load. Let us take dl, the distance moved by the load in t time. dl is the distance moved by the load in t time, and de, the distance moved by the effort in t time. So velocity of load is equal to dl upon t, and velocity of effort is equal to de upon t. Then velocity ratio is equal to de upon t divided by dl upon t, that is equal to de upon dl. So velocity ratio can also be explained as displacement of effort by displacement of load. What is velocity ratio? Displacement of the effort to the displacement of the load. Now here also there will be three conditions that will arise. Velocity ratio can have the values greater than 1, equal to 1 or less than 1. So it's a fraction. So velocity ratio's value can also be greater than 1, equal to 1 or less than 1. Now velocity ratio value, gain in speed, and we will have gain in speed. Velocity ratio value is equal to 1. Second one, velocity ratio less than 1 or velocity ratio greater than 1. Okay. For velocity ratio to be equal to 1, dE should be equal to dl. dE should be equal to dl. That is, the displacement of the effort should be equal to displacement of load. It will be only used as change in direction. So if velocity ratio is equal to 1, then the machine is used for changing the direction of the effort. If velocity ratio is less than 1, the machine is used for gaining speed. If velocity ratio is less than 1, then the machine is used as a force multiplier.